Alright, this is the solution video for numbers 25 through 30. So looking at number 25, it's just your regular rational exponent problem where if you can look at it and decide what the answer is, that's fine. But if you are the type of person that likes to change it to the radical equivalent, then 3 would go in the index and 4 would go as the exponent. So if we take the cube root of 8, that is negative 2. And then when we take negative 2 to the 4th power, we get positive 16. For number 26, power to a power rule says we multiply the two exponents. So 7 remains the base, that does not change. And then the square root of 3 times the square root of 3 is the square root of 9, which we know is 3. And then we take 7 to the 3rd power, and that gives us a final answer, of 343. Number 27, we do not have the same index number, so this is one of those problems where we have to rewrite them as rational exponents and change the base. So the square root of 3 is rewritten as 3 to the 1/2 power, and 4th root of 9 can be rewritten as 9 to the 1/4 power. In order to use our exponent rules, we have to have the same base. So that means we're going to need to change 9 to 3 to the 2nd power, since our first base was 3, and we can't change 3, so we had to change 9 to 3 to the 2nd power, keeping that 1/4 on the outside. So the next thing we need to do is our power to a power rule with that second term, so we multiply 2 times 1/4. So once again, that first 3 to the 1/2 isn't going to change, but then when we multiply 2 times 1/4, we get 2/4, which is also the same as 1/2. Now that we have the same base of 3, we can use our exponent rule. So the base does not change, and then because it's multiplication, we add our exponents. 1/2 plus 1/2 gives us 1 whole. 3 to the 1st power is just going to give us 3. Number 28, again, looks scary. It's kind of like that question on the previous page. However, the hard part's already done. We have the same base, so we can just apply our exponent property. Our base is square root of 3, but we have to be careful because we have two binomials. So since we're using our subtraction rule and we're subtracting a binomial, we have to remember that that subtraction sign applies to both of the terms after it, not just the first term. So it's square root of 3 to the pi plus 1 minus pi, but then minusing a negative 1 is the same as adding 1. So to be really careful with that. We have a positive pi and a negative pi, which cancel out. So then we get square root of 3 to the 2nd power, 1 plus 1. The square cancels out the radical, so 2 questions in a row, we get an answer of 3. 29 and 30, very similar problems. They look a little scary. However, we just have to change them to their radical equivalents. So cube root of 64 squared minus the 4th root of 81, all to the 2nd power. We know the cube root of 64, it's 4. And then we take 4 to the 2nd power. And then the 4th root of 81 is just 3. We don't have to worry about another exponent. So really what this question is asking us is 16 minus 3 all to the 2nd power. 16 minus 3 gives us 13, and 13 to the 2nd power is 169. Final answer. Right, so same idea for the second problem. So let's change 4 to the 1/2 to the radical equivalent, which is just the square root of 4, and then we're subtracting the cube root of negative 216. And then take that all to the 3rd power. So we have to be careful because we can take the cube root of a negative number. So the square root of 4 is 2, and then we're going to be subtracting. The cube root of negative 216 is actually negative 6. So we have to be very careful because subtracting a negative is the same as adding. So we get 8 to the 3rd, which is equal to 512. That will conclude this video for numbers 25 through 30. There will be one more video for 31 through 34.